So good evening to one and all. So myself Muhammad Abdul Rauf. So in this video, I'm going to start course called Probability and Stochastic Process. So most of the universities, colleges, uh, they'll be having this course named as Probability Theory and Stochastic Process (PTSP), and another name is Random Variables and Stochastic Process. So though we have different types of names or different names for this course, but most of these three will have same syllabus. So only the difference will be, so in the first unit you'll be having first part, first unit of the half part you'll be having about property theory. So the basic definitions, all those you are going to come across in this probability. So let me start uh, why we are going to learn this subject. So why we have to learn this subject, and the primary objective of this course is to solve the probabilistic problems in engineering and applied science. So most of us, whenever we start any course, so uh, most of us even don't know why we are studying. So we should know what is the primary objective of this course. And coming to this course, the primary objective is to solve the probabilistic problems in engineering and applied sciences. So let me tell you where you will come across the basics or uh, I mean background for this subject. Which subject will be acting as a background for this P and SPs? So analog communications, digital communications, all the communication subjects. So this P and SP is very important concepts will be covered in this P and SP. So this is a prerequisite subject for studying the communication subjects, uh, such as AC, DC, DSP, all this, all the communications subjects. So this is going to be a prerequisite subject. Right? So let us go for the next slide, that is course objective. As I said, the main objective we have already know what was the main objective. Now we'll see what is the course objective for the subject. The course objective for this subject is, so you can see on this, you can watch on this slide. First thing is, actually when we go to the syllabus of P and SP here, uh, I'm I'm preparing you to listen to this P and SP subject videos, all these videos. And here the total, I have prepared 5 course objectives, which resembles the syllabus of our P&SP, as the P&SP syllabus contains 5 units. So I have classified 5 course objectives. So first course objective, if you observe here, to expose the basics of probability theory and random process for their subsequent study of analog and digital communication. So this is about basic first objective of P&SP. In simple words, I'll say we'll be studying about the probability theory basics and random variable basics in this first unit of our syllabus. So coming to the next is to understand the basic concepts of random variable. So the basic concepts of random variable will be covered. Actually, it will be covered in the unit 1, and the extension we are going to see in the unit 2. Next, third objective, course objective, is to understand the differences between time averages and statistical averages. We'll come to know this in the third unit, what actually time average is and what actually statistical average is. So if you go through all these videos, you'll definitely you'll have a knowledge on this P and SP, and you can score good marks. And the next fourth one is to gain the knowledge about correlation functions, and the fifth is to learn about the applications of Fourier transform like spectral density. Right. So these are the five course objectives. And coming to the course outline, as I said, so this subject is having total 5 units. Unit 1 is about review of probability theory and random variables, and unit 2 is about operations on one random variable, and 3 is about multiple random variables, operation on multiple random variables. And unit 4 is about random process. So here we have random process, the other name is stochastic process. The other name for stochastic process is random process, and this random process will be having two characteristics we are going to study: temporal characteristics and spectral characteristics. Coming to this temporal characteristics, so we have, if I am going to uh, have a look at the time domain representation of random process, then we'll go for temporal characteristics. If we want to see the frequency domain, then we'll be going for spectral characteristics. And within this fifth unit we have second part, linear systems with random inputs. This is about, this is about the course outline of our syllabus, probability and stochastic process, right? So next, coming to the textbooks, so these are the textbooks you need to follow. You need to follow mm, two textbooks are, one is most popular one, that is Peebles, and second one is Propolis. So these are the textbooks you need to follow for this course, probability and stochastic process. Right. So let us start our first unit, review of probability theory and random variables. So before we enter into this probability theory, so I like to compare this course with our childhood learning. So when we started our learning, childhood learning, so first we started with alphabets, and then we have framed words, and then sentences, and then paragraphs, and then we start writing essays, right? So similar way, so we are going to first start alphabets. So those alphabets are nothing but basics about probability theory, so that we'll study in this first unit. So review of probability theory and random variables. So let me start. First definition of this probability theory is, what is a set? A set is a collection of objects called elements. A set is always denoted by a capital letter, and here we have an example. Capital N is equal to, a set consists of, here this set is a set of natural numbers 1, 2, 3, so on up to n. So this is about the basic definition of a set. Next, coming to the types of sets, so we have different types of sets. So within this, first is countable set, countable set, and uncountable set, and null set. So first we'll see what actually a countable set. The name itself says countable set. If the elements or events in an set can be countable, then we call it as countable set. It is very simple, and it is very clear. So the definition of countable set resembles the name countable. So if the elements of the set can be put in one-to-one correspondence with a natural number, then such type of set we call it as countable set. So I have given you the example. So capital A is equal to 1, 2, 3, 4, 5. So I can count these numbers. So we call it as countable set. Right. So coming to the next type of set, uncountable set. So here, if the elements of the set can't be put in one-to-one correspondence with natural numbers, then such set is called uncountable set. So here you can see example: a is equal to 5 less than a less than 19. So here so total numbers are, there are, we have, we cannot put all these numbers into one-to-one correspondence. So such type of set is called uncountable set. Coming to the null set. So a null set is, if there exists no elements in a set, then such type of set we call it as a null set. It is denoted by 5, and then 5 is equal to, so we don't have any elements on the set, then such type of set is called null set. Next type, finite set. A set having elements which can be counted uh, is called a finite. If I can count the number of elements in a set, then we call it as finite set. If we can't, so we call it as infinite set. So next, coming to the subset, say two sets A and B have taken two sets, A is equal to 4 5 and B is equal to 1 2 3 4 5. If the B contains all the elements of A, then we call A is a subset of B. Next, coming to the proper set, if A contains at least one element more than B, then A is proper set of B. So you can see the example. So by seeing the example, you can easily know the definition of these types of sets. So next is algebra of sets. So you have uh, just in this slide I'm showing you different types of laws: commutative law, distributive law, associative law, De Morgan's law, and duality property. So all the first three laws you know already. So fourth law is De Morgan's law. De Morgan's law states that complement of A union whole bar is equal to A bar intersection B bar. Similarly, A intersection B bar is whole bar is equal to A bar union B bar. Next, coming to duality principle. So duality principle is replacing of unions by intersection and intersection by unions. So next is, we'll move to the next definition, experiment. So any physical action can be considered as an experiment. Tossing a coin is an experiment. Throwing a die is an experiment. One example of experiment, and drawing a card is one example of experiment. In sample space, the set of all the possible outcomes in any experiment. So if I perform any experiment, if I get total possible outcomes, we call it as an experiment. We call it as a sample space, and it is represented by letter S. The sample space is a universal set for the experiment, right? Next, so sample space is of, can be of two types: discrete sample space and continuous sample space. The sample space of an event with countable outputs, either finite or infinite, is called discrete sample space. That means either finite or infinite, but I can count the output, then I call it as discrete sample space. If I cannot predict the output because of its analog nature, such sample space is called continuous sample space. That, see, very minute thing or very easy way of remembering these two types are: if the sample space is discrete, then we call it as discrete sample space. If the sample space is continuous, then we call it as continuous sample space. So next, what is an event? So event is a set of possible outcomes of an experiment. So only a set of possible, not I'm saying all the set of possible outcomes of an experiment is called event, and is a subset of sample space. If there are n number of elements in the sample space, then there exists 2 power n number of elements, events. The event will be a specific characteristic, whereas the experiment, whereas the sample space gives all the characteristics of the experiment. So next, probability. So here the probability can be defined in three ways. First one is classical definition, or second one is through knowledge of sets and axioms. Third is I can define the probability through concept of relative frequency. So let me stop here, and we'll continue in the next video or next lecture. So how we are going to define the probability through classical definition and all this will continue in the next lecture. Thank you.